Andarki Namaskaram, welcome back to Vamsi Bhavani. If you watch this video completely, I can assure you one thing, the time that you spend on learning any programming language will reduce exponentially, because in this video we will discuss concepts that are core to any programming language irrespective of what it is. It can be C, C++, Java, Python, JavaScript, C#, whatever. Whatever is the programming language, the core concepts always remain the same. It is just the syntax and lower level implementation which changes. But for a programmer, for a high level programmer, the core concepts remain the same. So if you understand these core concepts completely, it will be very easy for you to learn any new programming language, because then it will just be a task of learning those new syntaxes corresponding to the core concepts. That's it. So starting with our video, the first core concept is variables. So irrespective of the programming language, whenever you talk about programming, actually what are you talking about? Programming is nothing but taking data, having a task in hand and achieving that task by manipulation of data. So when you have input data, you do some operations and finally give some output, and these operations are based on your task to be performed. So performing these operations is something which I am referring to as manipulation. So as you can understand, data is very critical, very important for programming. That's the reason while we program, temporarily we need to store that data. So for doing that, for storing data temporarily in the program, for accessing it while the program runs, we store it in containers called variables. So variables are nothing but containers used to store data within the program. What do I mean by within the program? These variables are not stored in the permanent memory. These are only stored, these are only kind of existing in the memory as long as the program is running. Once the program has terminated, these variables will no longer exist because we no longer need that data. So variables are nothing but those holders, those containers who temporarily store the data. Okay. Next core concept is data types. Now, if you go to a grocery shop, you buy a lot of things. It can be oil, it can be rice, it can be sugar, it can be anything else. So once you get these things home, they are stored in different type of containers. What do I mean by that? Rice is stored in a big tin wherein the whole 25 kgs kind of fits into it. For sugar, we have small containers. For oil, we have bottles. So based on the type of, the attribute of those items, we store them into different containers. So we have different types of containers for storing different kinds of items. Similarly, while coming to programming, while we store data, there are different kinds of containers to store different kinds of data. So that includes, it can be, maybe the data can be a simple number. The data can be a number with a decimal in it. Data can be a character, data can be a name, data can be anything. So based on what are you storing, the properties that the data has, based on these things, we have different kinds of containers. So these containers, so these different kinds are called data types. So based on the type of data, we segregate them into different types and we place them in the correct container only, so as to have a proper usage. Now, why do we need these different data types? Very simple. Why do you need different containers for oil and rice? Just to handle them correctly. Yes or no? Similarly, to handle the data correctly, we have different data types. I hope that's clear. The third core concept is operators. Now, take any expression. Let's say A is equal to B plus C. What are operands here? Operands are A, B and C. What are operators here? Here the operators are equals, that equal to sign, and the addition sign, plus. So these both are operators. So what does these operators do? These operators simply tell us the operation being performed within the different operands. For example, take plus. So this operator plus tells us that an operation called addition is happening between B and C. What does equal say? Equal says that there is an operation called assignment wherein RHS, right hand side, is being assigned to LHS, left hand side. So here what's happening? A is kind of being assigned with the value, with the sum of B plus C. So B plus C is an addition operation, which is suggested by plus, this is being assigned to A and E is suggested by equals. So these operators play a very key role, because when I say manipulation of data, we are performing various operations. So to make sure that these operations are being performed correctly, we need the correct operators. So again, knowing these operators is again one of the core concepts. Then we have two main core concepts, namely conditionals and loops. Without conditionals and loops, there is no programming language, because only with the help of these conditionals and loops you can add logic to your program. Now discussing them one by one. So conditionals says that whenever there is a condition, based on the result of that condition, let's perform an operation. Let's take an example. Let's say the weather is kind of cloudy and your friend just called you. He is asking you to come for a movie. So now you will make this decision based on the condition of the weather. Let's say if it starts raining, you might not go to the movie. But let's say if it's not raining, then you might probably go to the movie. So here you're performing your operations, you're performing your actions based on a condition called will it rain or not. So here you're performing operation based on result of that condition. So if you want to implement the same logic in programming, we need conditionals. So in conditionals, we use a condition, and based on the result of the condition, we perform the next operations. So coming to the next core concept, which is loops. Basically, to make machine perform similar tasks repeatedly, one after another, we use loops. So loops, as the name indicates, they are just kind of constructs which are used to make an operation be performed repeatedly. If you want to perform a set of operations repeatedly, you use loops. So loops are nothing but a way of performing a single operation multiple times, again based on a condition. So until a condition is satisfied, a condition is kind of successful, based on that, until that is being satisfied, you kind of continue to execute, continue to perform the same operations repeatedly. So that is all about loops. Then we have our next core concept, which is functions. Now let me make one thing very clear. Functions is not a must-have in every programming language, but functions is a good to have kind of a feature. Even then, every programming language has functions. Why is that? I mean, on one hand, I am saying that you can do everything even without functions, but on the other hand, I am saying that everyone uses functions. The reason is it makes code maintenance easy. See, because let's say today you are writing a piece of code, and later after 6 months you come back to see the same code, but you are not able to understand what you have already written. So this is called readability. So to maintain code properly, to maintain code efficiently, in order to have the same code running for several years, maintenance, the ability of people to come back and read that code is very important. And if the code is cluttered, I mean if there is no clear distinction between what operation is being performed in this line and what operation is being performed in the next line, if we don't have that clarity maintained in the code, then it is really difficult to maintain that code. For that purpose, we have something called functions. Now functions is nothing but a simple concept wherein we write a block of code which is used for a specific task in a separate place. So what we do is we have something called function names, and under these function names we write that specific block of code. So what happens is whenever you need to kind of perform that task in the program, you just call that function, and whenever you call it function, that particular block of code is automatically executed for you. So you need not write the same code repeatedly, and at the same time the code readability, the code maintenance becomes very easy. Coming to our next core concept, it is file handling. Now, as I said you in the beginning, data is very critical and important factor of any program. So it's not necessary that every time the user manually feeds in the data and the user manually takes out the output data. For that purpose, we several times have files. So we read the data as input from the file and we write the data as output to the same file or maybe a different file. So for that purpose, we have files in place. So to handle these files, to open the file, to close the file, to write to the file, to read from a file, all these operations are done as a part of file handling. So again, file handling is core because every time user cannot manually kind of handle data, it can be either input or output. That's the reason again file handling is very important. The next core concept is exception handling. So several times we have code behaving in a way that it is not expected to. For example, I am writing a code wherein I am saying C is equal to A by B. That is, C is equal to A divided by B. So let's say here A and B are taken as inputs from the user. So let's say if a user by mistake enters B as 0, this will lead to something which is not expected, because we would not expect someone to come and say, please give me the answer for 2 divided by 0. Obviously, right? So we did not kind of have that in place, but this is something that can happen unexpectedly. So we need to handle these. These kind of situations are called exceptions, and we handle these exceptions using, it can be try catch or whatever, it is dependent on the programming language that you're talking about. But again, there is something called exception handling in place in almost every programming language. Again, that's a very core concept. So with all this discussed, let's move on to OOPS concepts, object-oriented programming concepts. Now, in object-oriented programming, what do we do? Basically, object-oriented programming is not something that is compulsory. It is a paradigm. It is a way of programming which leads to efficient results. So that's the reason many people use OOPS-based concepts. Now, the main and the important concept in OOPS is basically classes and objects. So what are these classes and objects? So as the name indicates, object-oriented programming has to do with something called objects. So what are these objects? So objects in object-oriented programming kind of refers to real-world objects. Basically what happens is, if you don't have OOPS in place, you cannot handle real-world objects as they kind of exist, because any real-world object in this world has two main things. One is properties and second is functionalities. So every real-world object has what? Set of properties and set of functionalities. So let's take a simple example. Let's say we are talking about this mosquito killer. So this kind of a real-world object has various properties and various functionalities. Various properties include its color, its shape, its kind of volume, the capacity that it can hold, the number of watts that it consumes. So these are all the properties of this object. So now what are the functionalities? The functionalities are to start when plugged in, to stop when plugged off, to kind of use this liquid in the bottle below and kill the mosquitoes. So these are its various functionalities. So to define its properties and functionalities in one place, we need OOPS. So in OOPS, what happens is, we have two concepts, which is classes and objects. Now what are classes? Classes are like blueprints. Let's say I am building a house. So for that house to be built, first of all, I'll plan. I'll have a blueprint ready. So based on the blueprint, I will implement that blueprint and build real world objects. So I can have, let's say, a blueprint. I have a blueprint, a plan of a house. Now I can use the same blueprint to build several houses in several places. So those houses that are built are objects, and this blueprint, kind of a plan for those houses to be built, for those objects to be created, we have a class. Okay. Now, as I just told you, holding functionalities and properties together is the first feature of OOPS, which is called encapsulation. The next feature is inheritance. Now let's say I have the same example again, a mosquito killer. Now I want to make a similar machine which is more advanced than this machine, but I don't want to again kind of explicitly define the features, the functionalities once more. I just want to use the same features and functionalities in this, but at the same time I want to add some advanced features like having a button which when pushed kind of brings it to active mode or passive mode based on the kind of the push that you make. So I want to add that advanced feature to the same machine. So what I'll do is, instead of defining these properties and functionalities once again, I'll kind of make a child class for the same class which kind of is used to implement this object, and use that class to make the new advanced machine. So this kind of feature of reusing the existing class and making it advanced by adding some of the new features or functionalities is known as inheritance. Then the next feature of OOPS is polymorphism. So polymorphism is an ability to work in different ways based on different conditions. Let's say, I'll give a simple example again. This might not exactly reflect the main concept, but to understand, let's say this is a machine. This machine can work with this liquid or liquid of some other company as well. So this kind of works with both of them based on the kind of liquidator or this container that you fit in. So this is an example of polymorphism. I mean, that's an high level understanding. For example, there is a function that computes area of the shape. So based on the number of parameters that you pass, it computes the area accordingly. For example, if I just pass single attribute, single value for a function, and it has to compute area. So it can take it as kind of radius and compute the area of circle. Let's say I pass two parameters. It can take them as length and breadth and find the area of a rectangle. So this is called polymorphism. The final most important feature in OOPS is abstraction. Basically, abstraction means hiding the details which are not required, which are not necessary. For example, as long as this machine is killing the mosquitoes, I really don't care how this liquid kind of goes through this machine and comes out and kills the mosquitoes. So hiding the unnecessary details, unnecessary stuff is called abstraction. And finally, we have something called data protection, which makes sure that the properties and functionalities of one class is not shared with the properties and functionalities of the other class. These are all the core concepts that are included in any programming language, especially OOPS based programming languages. I hope you have understood this and this video is helpful. Thank you very much. Jai Hind, Jai Bharat.